Example 6. Find a formula for f inverse and give the domain and range of both f and f inverse. Then sketch both functions on the same coordinate axes. The original function here is the cubed root of x plus 2 minus 5. This example is laid out just like examples 4 and 5. We've got a grid where we can graph both the original function and the inverse function, and then there's a spot at the bottom to write down both the domain and range of f and the domain and range of f inverse. Okay, I'm going to start by working with f, graphing it, writing down its domain and range, okay, and then we will jump into the inverse function here, okay. I'm going to start by graphing this thing, okay. This is another transformation problem here. The parent function is going to be the cubed root of x, okay. So I'm just going to put little x's here for this parent function. The cubed root of x goes through 0, 0, 1, 1. It goes through 8, 2. And then it goes through -1, -1. And then -8, -2. Okay, and then we are adding 2 inside of the radical. Okay, so remember the root acts like parentheses. If you're adding inside parentheses, that means we're going to go to the left. So we need to shift left 2, and then we're subtracting 5 outside of the root or outside of the parentheses. And so that means we need to go down 5. Okay, so I'm going to take each of these little x's and I'm going to go left 2 down 5. Okay, so left 2 down 1, 2, 3, 4, 5. Okay, and then left 2 down 5. And then left 2 down 5. Okay, left 2 down 5. And then left 2 down 5. Okay, I'm going to erase my x's. Okay, so here are the dots that the original function will go through. Okay, remember it's going to have an S shape. Okay, so this is the original function. Okay, all right. So if you look at this, okay, if you try to write down the domain here, the domain is going to be all real numbers. Okay, you know this from the formula. The domain of a cubed root function is all real numbers. Okay, also the leftmost point on the graph, okay, is -infinity in the x direction. The rightmost point, because the graph keeps going, it's going to be +infinity in the x direction. Okay, as far as the range goes, you have to get this from the graph. Okay, this snake, it is climbing in this direction very slowly, and it is descending in this direction very slowly. Okay, eventually this will decline to -infinity in the y direction. Okay, but it's going to take a long time. Eventually this side will climb to +infinity in the y direction, but again, it's going to take a long time. Okay, domain and range of the original function is all real numbers. Okay, so now that we have a graph, we've got our domain and range, we can concentrate on finding the inverse function. Okay, so I'm going to follow my steps. First thing I'm going to do to get the inverse, I'm going to replace f of x with y. And then in the next step, I am going to switch x and y. Okay, so I'm going to get x equals the cubed root of y plus 2 minus 5. Okay, I just switched x and y. Okay, now we want to solve for y. Okay, y is trapped inside the cubed root. Okay, so the first thing we're going to do is isolate the cubed root. Okay, so this -5 is separate from the cubed root, so we're going to move it over. Since I'm subtracting 5, I'm going to undo that by adding 5. So we're going to get x plus 5 is equal to the cubed root of y plus 2. Okay, all right, so let's keep going. Okay, I'm going to come up here. I'm going to switch. I'm going to put the stuff with the y on the left side, and then I'm going to put the x stuff on the right. Okay, y is trapped inside the cubed root. Okay, this whole quantity, y plus 2, is trapped by the cubed root. Okay, so to get it out, we have to get rid of the cubed root. Okay, to get rid of a cubed root, you just need to cube that side. Okay, if you do it to the left side, you have to cube the entire quantity on the right side, okay? On the left, the cube and the cubed root will cancel, leaving you with y plus 2. On the right, we're going to be left with x plus 5 quantity cubed, okay? Y is almost by itself. It's attached to a plus 2, so to undo that, we're going to subtract 2 from both sides, okay? So we're going to get y is equal to x plus 5 quantity cubed minus 2. Okay, there is no way in the world you're going to get me to multiply out the x plus 5 cubed, so just leave it alone. Okay, your last step is to replace y with f inverse of x. This is your inverse function. Okay, here it is. This is the formula. All right, so we can go ahead and graph this guy and then talk about its domain and range. Okay, so here we go. Okay, we've got our inverse function. Notice it is another parent function. Okay, transformations are back. Okay, this is x cubed. Okay, that's the parent function. Okay, so I'm going to go ahead and put little x's for x cubed. X cubed goes through 0, 0, 1, 1, 2, 8. And -1, -1, and -2, -8. But now I need to do the transformations, okay? So since we're adding 5 inside the parentheses, that means we need to go left 5, and then we're subtracting 2 outside of the parentheses, so that's a vertical shift down 2 units, okay? So each of these x's needs to go left 5, down 2, okay? So I'm going to start right here, left 5, down 2. It's going to bring me right here. And then left 5, down 2. Left 5, down 2. Left 5, down 2. One more point. Left 5, down 2. Okay, these red dots are points on the inverse function. I'm going to go ahead and erase the little black x's because I don't need them anymore. Okay, and so here we go. Okay, this is kind of the vertical S shape. Okay, so this red graph is F inverse. Okay, we've got our formula, we've got our picture. Okay. The red graph and the blue graph are indeed symmetric about the line y equals x. Okay, here comes the line y equals x. Okay, if you were to fold the sheet of paper along this black line, the red graph will lie on top of the blue graph. Okay, you can check it out with points. Let's see here, 10, is this -7? Or sorry, -10, -7 is a point on the original function. So that means if we switch x and y, we should see -7, -10 on the graph of the inverse, and we do right here. Okay, and you know, we can kind of check a couple of points here. Let's see, I'll check another one. Let's look at this point over here. 6, -3 is on the original function. So if I switch x and y, I had better see -3. Let's see here. I had better see -3. Ooh, it's not matching up. If I see 6, this is why you do little checks of yourself. See, if you see 6, -3, that means you need to see -3, 6 on the graph, and I have -3, 7. Okay, this is what happened. I made a little mistake, so let me go ahead and fix it. On the parent function x cubed, that should be 2, 8 should be there on the parent function. So I needed to go left 5, 1, 2, 3, 4, 5, but I only went down 1 instead of 2. So it should actually be right here. Okay, so let me go ahead and fix that. Okay, it's easy to fix. Okay, so here, this point should be, let's see here, down, or sorry, left 5, 1, 2, 3, 4, 5, down 2. Okay, so there you see, okay, -3, 6 is indeed on the graph of the inverse. Okay, so it's all checking out. Okay, this is why I tell you to check yourself. Okay, it's really easy to make a mistake. Okay, so since 6, -3 is on the graph of the original function, okay, we do indeed see -3, 6 on the graph of the inverse. Okay, And you can check the other points if you want to, okay, but they should check out, okay? All right, so we've got our inverse function formula, okay? We've got the original and the inverse graphed, okay? Let's go ahead and talk domain and range of the inverse function. This x plus 5 quantity cubed minus 2, it's a polynomial. If you were to multiply out the x plus 5 times x plus 5 times x plus 5, if you were to multiply that out and then subtract 2, that's going to be a polynomial. So the domain is going to be all real numbers, okay? And then if you check out the range of the inverse, if you look at the rad graph, the graph goes down, 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 down forever. So the lowest y value on the curve is going to be negative infinity. And then if you look at the high point, it goes up, 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 up forever. So the highest y value is going to be positive infinity, okay? We are seeing that the domain of f is the same thing as the range of f inverse, and the range of f is the same thing as the domain of f inverse, okay? Everything should agree